Welcome. In this video, we're going to look at one of the problems under projectile motion. So this is a question that requires us to come up with an expression to say show that y is equal to x tan theta plus gx squared over 2vo squared, open brackets, 1 minus sine squared theta. So this is the question, or rather this is what we are required to come up with after figuring out this question. So in this scenario, we have been given this diagram where an object is projected at an angle, which is the theta, and it is having the initial velocity of v naught. And then this object covers a vertical displacement of y, which is the height. And then it covers, when it comes to rest, it covers a horizontal distance of, or displacement of x, which is the range. Now, from this, sometimes when we just see questions of this kind, like just like this, we tend to think to say the concept that is needed to figure out this may be cumbersome or maybe too complex. But I can assure you to say, if you just know the concepts, if you're able to connect one concept to another, then we're going to face little or no challenges. So from this, we're going to begin with the most basic information that we have. And we know from motion, since it is projectile motion, that this one, which is displacement, so in this case, we're looking at vertical displacement. Okay, for the first one, let us come up with some equations. So y is equal to ut plus half at squared. We know this one so well. We know this one so well on the equations of motion. So from this point, we know that the only acceleration that is acting on this object, it is acceleration due to gravity. So where there is a, we can replace it with g. And from this point, we know that since this is projected at an angle, we can resolve the velocity, the two velocities, the vertical and horizontal components of this velocity. So we can do this. So we have something like this, where we have this as theta, this one as VO, and this one, which is the Vy. We are in Y, then this is the V in X. And then from this point, what we're going to do is we're going to come up with the SOHCAHTOA. From this, we know that sine is equal to opposite over hypotenuse. So sine theta, which is sine theta, so we are dealing with this one, is equal to opposite is Vy over hypotenuse, which is VO. So if we make Vy the subject of the formula, we're going to have Vy is equal to VO sine theta. So from this, in the similar manner, we are going to come up with this one, cos theta is equal to adjacent over hypotenuse. So we have the adjacent, so cos theta is equal to adjacent, we have Vx over hypotenuse, which is VO. So making this the subject, we're going to have VO or Vx is equal to VO cos theta. So this is what we have, and then we have for tan. So tan theta is equal to opposite over adjacent. So we have opposite over adjacent. So Vy over Vx. So we have our Vy over Vx, and then Vy, it is this. We have VO sin theta over VO cos theta. This and this can even go. What we're going to have is the tan theta, which is this one. Now, I just wanted you to have some information on how to go about this. So let me even erase this. So we now have this information to say y is equal to the vertical displacement, okay, which is so Vy Vyt plus half, where there is a, we put g, then t squared. So from this, remember what we found for this, we have VO sin theta t plus half gt squared. So let us call this as equation 1. Since we want the range, which is the horizontal displacement, we have V is equal to distance over time, of which we know that, okay, over time. So our x, if we make it the subject, we're going to have is equal to vt. But since it is in x, it is x. And the velocity we found in the x, or the horizontal component of the velocity, we had vo cos theta. So we also put t here. Let us find the expression of t so that we put it in this equation. So we have vo cos theta, even here vo cos theta. So that this and this will go. So our t will be equal to x over vo cos theta. So let's call this equation 2. So without even wasting much time, we can say equation 2 into 1 is equal to. So we put this in this, we are going to have vo sine theta, where there is t, we put x over vo cos theta plus half g, so x over vo cos theta. So this one squared. So from this, when this multiplies with this, we're going to have x vo sine theta over vo cos theta plus half g, okay, so this one x squared will be x squared. So x times x will be x squared, okay, over v cos theta squared, we're going to have vo squared cos squared theta. So from this point, remember what we found on the trig ratios tour, sine theta. So this and this will cancel. So we're going to have sine theta over cos theta. And from trig ratios or trig identities, this is the same as tan theta. So x tan theta, sine theta over cos theta is tan theta. So from this, we can say, so this one we have half gx squared over vo squared cos squared theta. So from this, we know from trig identities again to say cos squared theta plus sine squared theta is equal to 1. So since we have cos squared theta here and we want to come up with this, so we are going to have cos squared theta, we make it the subject, is equal to 1. When this one crosses the equal sign, it is going to be negative sine squared theta. So from this, we call this as equation in, okay, so let's call this as equation 3. And if we say this is equation 4, so this into this, we're going to have y is equal to x. And this is the needed expression from this one. So this is how we should go about this. Thank you so much for watching the video.